Welcome back, students. I have a student who's asking a question. I'm going to bring us over there now to the question and we'll take a look at it together. Okay, now here's the question. It was number 17 in this student's work. It says, suppose the function, and then we see a function there, describes a physical situation that makes sense only for whole numbers between 0 and 10. For what value of x does f reach a minimum? And what is the minimum value? Suggestion, we suggest beginning with a table and starting at 0 and an increment of 1 and carrying on. Okay, so here's the way I would ask you to do something like that. The formula, I'm going to jot it down, is f of x equals 45 minus 9x plus x to the 4th over 10. Okay, I want to talk to you guys for just a minute about this expression right here. This is a little fraction of its own. You may make the mistake of thinking that it's all of that over 10. It's not. It's not 45 minus 9x plus x all. It's just x 4th over 10. If they wanted that, they would have put parentheses around the 45 down to the x to the 4th. Okay. So now that being said, let's take a look now at Desmos. I'm going to go into Desmos. Okay, and when you get into Desmos, you can go right to Graphing Calculator, like so. And I'm going to put that formula in here now, but I'm going to write it as y equals. And as a reminder, I encourage you to always try to use y and x all the time. If it's like in terms of c and n, I would try to switch to x and y. So this is going to be 45 minus 9x plus x to the power 4 over 10. Now, that is a function, and I kind of don't care what it looks like, but for the record, I could zoom out to see it. Here it is, okay, FYI, but nobody really cares about that. What matters here is that we need a table. This is tabular analysis. So what I'm going to do is I'm going to change this into a table right now by clicking the little gear and then clicking table like this. And then, as you can see, I have values for -2, 1, 0, 1, and 2. But what I'm going to do is I'm going to carry on by clicking on that 2 and hitting enter. And suddenly, quickly and easily, I have the first 10 answers. Where is the minimum? Let's take a look here. Looks like the minimum is probably this one. Let's see. Yeah. So to answer the question, x equals 3 will give the minimum value, and the minimum value will be 26.1. We do have a second question. Let's take a look at that one. For the next question in our exam review, I have a student who's asking about the profit here. The question reads, the yearly profit P for a widget producer is a function of the number n of widgets sold, and the formula is given here, and we have a formula. P is measured in thousands of dollars, N is measured in thousands of widgets. And the formula is valid for a level of up to 20,000 widgets. Make a graph of P versus N. All right, first and foremost, the fact that it says that the graph is valid for up to 20,000 widgets is telling you that the very last number here could be 20. Or if you're going to graph it, that we expect for it to only go up as far as 20 for all the graphs. That's the first idea. The next important idea I have is I'm going to take this formula and I'm going to plug it into Desmos, and I'm going to try to match the axes. The formula, let me jot it down, is P equals -180 plus 100n minus 4n squared. I'm going to rewrite that, friends, to be y equals -180 plus 100x minus 4x squared. Like that. And the reason why, like I said, in Desmos, it's a little bit more practical to use x and y. Okay, so now let's go over to Desmos. Before we go to Desmos, there is one other important thing I want to mention. I want you to look very closely right here. Notice that our axes on these answers go from -200 to 600. Look at that. It happens down here too, and in here as well. What does that tell you? What is the y window? The y window, and I'm going to jot it down here for us to make it clear for everyone, because it's a little weird, but let me make it really clear for everybody. The y window is from -200 to 600, right? What is the x window? The x window, I'll do that in blue, The X window is right here. Look, it goes 0 to 20. The X window is 0 to 20. All right, so that be the case. Okay. Why, excuse me. Excuse me. Why am I saying that? Why is that so important? Because in the graph of Desmos, when you first look at Desmos, the window that they give you is a perfect symmetrical image with the origin right in the middle, and it only goes from like -10 to +10 and so on. Take a look. Right? See, so I'm going to clear all these drawings. Instead of that, I'd like to have a specialized kind of window. Let me close this out and let me go to the wrench. In the wrench, I'm going to tell them to tell me what the x-axis is from 0 to 20. See how I'm changing it? This is the key to getting answers like this on funny looking graphs that are in WebAssign. The y-axis we have determined should go from -200 to 600. Doesn't it look a little bit better now? It looks kind of like the multiple choices a little bit if you look. Now let's put the formula in. The formula was in terms of p and n, but I'm going to deliberately use y and x instead. It'll be y equals -180 plus 100x. What happened? 100x, got it, minus 4x squared. To get squared, you could do the up caret, which is shift 6, or if you want, you could come over here to the little keyboard and you could type this one and it goes up there for you, okay? Now, look familiar, all right? Okay, now let's take this image and look at it. It looks like right here we have an important point of like 12.5445. I can tell right here that it's going through right at about 2. I'm going to use those ideas when I try to select what the graph is. So let's take a look now at the graph. Right now, I'm not sure if it's supposed to be this one or this one, but I know it's not this one. Not what I meant to do, sorry. There we go. I know it's not this one. Why do I know it's not that one? Because we already confirmed it kind of goes through 2. Like, in other words, I like what I see right here. And I like what I see right here. But this isn't going through 2. Look, this isn't going through 2. I'm starting to feel like I don't think this is it either. And it's definitely not this one. Let's look one more time at the actual picture. So it does appear to be going through 1.952. So I'm going to say that this is the answer. Right here. Oh, look, they have the key. It looks like you saw the answer, which is good. Oh no, I think we're looking at it through my perspective. You don't see the key, but we do, looking at my perspective. It's telling me that this arrow here is telling me that the student answered that and it was incorrect. You were very close. You were very close. It's very much like that. The difference was examining very closely for that intercept right there. See, and you could see I expected to go through around 2. That's why that's incorrect. Let's look at the rest of this question now. Calculate P of 0. The student got this one correct. All you have to do is just go back to this formula right here and put the 0 in. What happens is all of these things wind up knocking out. If this n is 0, then this is gone and this is gone. You just have -180 left. Okay, so that wasn't too hard. Let's see what the next part reads. It says, explain in practical terms what that means. The producer will have a loss if no widgets are sold. That's just it. In other words, if 0 is the value of n, meaning if there are 0 widgets sold, then the answer is -180 will be what the profit is. And a negative profit is a loss. Okay, then it says, what profit will the producer make if 11,000 widgets are sold? The mistake that was made here, friends, is that, remember they told you that it was in thousands. Look very closely at the wording. N is measured in thousands. See that? P is in thousands of dollars. N is in thousands of widgets. So if we're telling you 11,000, then you just let N equal just 11 only. Okay, and we could get that quick looking at Desmos. If I go to Desmos and get the table back, I could just type 11 there and give you negative. It'll give you 436. So 436 is what we wanted there. And then that's 436,000, right? Okay. Next, the break-even point is the sales level at which the profit is 0. Assume the break-even point for the widget calculator, for the widget producer. Well, if the break-even point is where the profit is 0, then we're talking about this special place right here. If it helps, you can put it in a new formula, y equals 0. Look at that line right there. See how it crosses at 1.952 comma 0? That's the answer, but that's 1.952 thousands. So it should be 1952. Let's see what the answer is. Oh, maybe I'm wrong. 2,000 widgets. Well, approximate. See how it says approximate there? That's why we should say 2. And if you look, it's about 2. It's not exactly 2, but really it looks like it's 2. The next one says, what is the largest profit possible? The largest profit possible, take a look at this graph. Obviously, it's a parabola, and I know that you guys have studied parabolas before. Well, is it a parabola? Actually, it's not a parabola. Let me take that back. Let's put it this way. Whatever this function is, it clearly has a max, right? No, it is a parabola. Why am I all, yeah, it's a parabola. Click on it. Click on the parabola. Click where you think that the thing might be. And look at how it highlights it for you. That is the very highest possible place. Desmos really just pops it out for you. It's easy. They really show you the max right there. They make it as easy as they can. If you just click somewhere where you think it might be, Desmos says, you're trying to find the max, aren't you? Here it is. So the max occurs at the sale of 12.5 thousand widgets. The max profit will be $445,000. That's what we're looking for there. It has to do with finding the max. The good news is we don't have to understand parabolas and the HK format and all that good stuff about the vertex and the axis of symmetry and the whole game of parabolas you learned in Algebra 2. You don't need to know that. You need to know how to use Desmos. If you just click it in Desmos, it does appear quick and easy. Okay, let's take a look and see if there are any other questions in the meanwhile. And, we're going to stop our recording now. Thank you for paying close attention. If anyone has any other questions about it, that's why I'm here. I'll stop our recording here and come back if you have anything else you'd like to say. Okay, so for this question, friends, we're saying, suppose the function describes a physical situation. It's the same thing. So what I'm going to do is I'm going to go in and I'm going to check out Desmos and I'm going to put the formula in. And then I'm going to do a tabular analysis and then go look at what it says for 4. The function is 50 minus 8x. Minus 8x. What else? Plus x over x to the 4th over 40. Okay, so when I click this, the next thing I could do is I could click the gear and go get the table and start looking at all the values. You can just click onto it and enter a whole bunch of times. Now, as we mentioned earlier, the minimum value was the 4, and the reason why is because the lowest number we got was 24.4. It looks like the student probably got 191 from the next number. I don't know where that came from. Well, either way, I hope that makes sense. That's how you should have done this. It might have been just that maybe you were looking at the wrong table. Sometimes if you have more than one table in Desmos, you accidentally look at the wrong one or something. But that's why whenever I go back into Desmos to do another question, I always click the box and get rid of everything. So I put the formula in. I found a couple of values with the table. And then for 4 was the lowest. Right here, if I look at all the numbers, that's the lowest one. And then what is the actual function value is 24.4. For the next question we're looking at, it has to do with the letter E, and E is Euler's number. I'm going to give a little bit of a discussion about that. Euler was an amazing, talented German mathematician, and you can spell Euler like this, even though it may feel like Euler. It's not Euler, it's supposed to be Euler. And E is a number that is approximately 2.71. Now, What you need to remember about E though is there's a long story about why E is that number. It's called the transcendental number. It's irrational and it's a beautiful story. But what we need to know is how to use it in terms of math models. So when you use Desmos, all you have to do is literally just type the letter E and it knows, oh, you mean the irrational constant 2.71. So we're going to use that and we're going to be very careful about putting this formula in when we need to put it in. Okay, that being said, now E is not a weird thing. Let's see if we can read through the question. It says if you borrow this much money at an APR of this percent in order to buy a home, and if the lending institution compounds interest continuously, then your monthly payment, M, in dollars depends on the number of years, Y, that you take to pay off the loan. The relationship is given by this formula. Now, make a graph of M versus Y. So what we need to do is we need to carefully put that whole ugly formula into Desmos. Let me jot it down. And watch out for those decimals. That's 0.005, and that's very easy to make a mistake with. Questions like these are called sigmoids or logistics because they have a 1 minus a number to a power down there. All right. And also notice that they're using Y as the independent variable. That alone will throw people off. Usually X is the independent variable. So in this case, what I'm going to do is I'm going to swap out M will be Y and capital Y will be X. Okay. Now, let's go ahead and put this formula in. I'm going to close this. I'm going to start putting the formula in. Now, as I'm putting the formula in, you know it's kind of complicated. So I'm going to be using parentheses a lot. And I want to use, whenever I type in a decimal, I like to put 0.00. And the reason why is because it's a little bit easier to see that way. If you make E to the 0.005, it's not as clear as E to the 0.005 because that period does kind of really fade away, you know. So putting 0 in front of it kind of helps it just a little bit. So I'm going to do that. Let's start with Y equals instead of M equals. And now my numerator is going to be, and I'll use parentheses for it. Or, you know, for something like this, let's not use parentheses. Let's just go with the fractional structure. If you look down here on the bottom, you'll see it says functions. I guess they don't have it there. I thought they had a fraction thing. Maybe they don't. Okay, my bad. I guess they don't. Do they? Am I crazy? I thought they did. I guess they don't. That's okay. All right, so what we'll do is we'll write the numerator out first. 120,000 times E to the power of, notice E is italicized, E to the power of, which is shift 6, and then 0.005. To get out of the exponent, I'm just going to hit the right arrow like that. And now -1, close the parentheses. Okay. Next, what I'll do is I'll just hit the slash. And you'll see the whole numerator, the whole thing has become a numerator. Now in the denominator, I'm expecting 1 minus E to the power, and make sure you do this right because this is very easy to mess up, to the power negative O. See, I messed it up. Shift 6 to get up into the exponent negative 0.005. And now it's, no, negative 0.06, isn't it? Yeah. To the times capital Y, or lowercase x in this case. Now, that's the function, it's in there. What does the graph look like? Let's zoom out a little bit. Pretty nasty, right? Now, the good news is we don't really care about the graph anyway. We're going to look at the tabular analysis. Let's just go and reiterate what the question was one more time. It's saying make a graph of M versus Y and then choose the graph. Now, I want you to look closely with me at the actual axes and the actual increments on the axes. Notice here that we're going from 0 to 30. Would look something like this. Right? Then notice here on the Y, I'm going from 0 up to 2000. So for Y, I would say something like this. 0, y 2000. I'm going to use these two limits in the wrench in Desmos to show Desmos where I'd like to see graph paper going. I want the graph paper to go from 0 to 30 on the bottom. I want the graph paper to go from 0 to 2000 on the y. So let's first do that. Well, let's secondly do that. I'll go to the wrench right here. Let me get rid of these things. Oh, I'll leave them there for a minute. I'll go to the wrench. Now I got to get rid of them. So on the x, it's going to be 0 to 30. And then on the y, I want 0 to 2000. Now it looks like one of the answer choices, doesn't it? Click the wrench to get that out of there. All right, some points here that I like. Well, generally, I see that it kind of starts right here and carries down that way. Let's see if there are any that kind of look like that. I'm going to go with this one right here, and you can see the key is there. That means that's the right answer. Okay. Next, express in functional notation your monthly payment if you want to pay the loan for 12 years. Now, remember that this is in terms of y years. So y is in terms of years. You have to look at that. Because if y is in terms of months and they want it in years, then you're going to need to do a conversion, but we don't need to convert here at all. So if y is in years, and we're telling you that you're trying to find the functional notation for 12 years, functional notation is simply m of 12. Functional notation is very simple. It's not math. It's just writing it in a certain kind of style. That's the answer they want for part B, is to just put 12 there. Next, use the graph to find its value. You could use the graph to find its value if you want, or better than that, use tabular analysis. What happens in the specific case that the independent variable is 12? Well, let's take a look at this and change this into a table now. And let's put 12 in there and see what we get. You would be wasting your time if you did this with math and with a calculator. Use Desmos. Look how quick and simple it was. There it is, 1171. The answer, as you can see, is 1171. Here it is. Now it says round to 2 decimal places. So, 953 rounds to 95. So what? Use the graph to find your monthly payment if you pay off the loan in 18 years. Now, this is, after all, just the same question again, except in this quick question, we're going to use the number 18 instead. So let's put 18 in there. 9, 10, 81, right? There it is. And then is there one more question down here? Okay, from part B to part C of this problem, you increased the debt period by 50%. Did this decrease or increase? Did this decrease your monthly payment by 50%? And the answer is no. So think about that for a minute. That's a pretty strong statement. That's very, very practical in a modern world where we're all going to work and paying bills. Think about that with me. It does say that you increased your debt period by 50%. Instead of 12 months, you're going to be paying it off in 18 months. Did that decrease your monthly payment by 50%? No, it did not. Your monthly payment did not get cut in half. It didn't go from 1170 to 575 or whatever. It went only down to 910. And the point of the matter is, it's not exactly perfectly equal that way. There's a lot involved. That e to the 0.005 and all that complication there makes it that you can't just assume if you do it. Like, you could also go in the other direction. Say, well, what if I pay it off in half the time, in 6 months? If I pay it off in half the time, will I have to pay double? No, you won't. So that's the idea that they're trying to say there. That's why the answer is no. Cold math will tell you that no, it's not 50%. It is 910. 910 is not half of 1171. The next question here is the graph concave up or down? The answer is the concave up, and the reason why is because it appears like a bowl. Remember, if you can hold the bowl and it's raining, it catches the water, it's concave up, it looks like a smile. If you're doing an umbrella and the water falls down around it, it looks like a frown. That's down, it's concave down. This is a concave up. All right, carrying on. Explain your answer in practical terms. And the answer we have here is, as the length of the loan increases, the monthly payment decreases at a slower and slower rate. And that is the case because if you think about places in the graph right here and here, it's decreasing. It's decreasing slower from that green check mark to that green check mark. It's increasing even slower from that green check mark to this one and so on. So decreasing slower, excuse me. I think you understand what I'm saying now, but it is decreasing slower. Like it's not as steep of a fall as you carry on. That's why that's the answer they were looking for there. And then last but not least, calculate the average decrease per year in your monthly payment from a loan from 15 years to a period of 18 years, and then round. So the way you're going to do that is your old-fashioned slope. You got to go in and find out the values for 15 and 18, like so. We have 18 right there. Here's 15. The numbers are 15, 1013.60, 18, 910.80. These numbers are like points, and we're going to use those points to get answers. I'm going to write right now here with those points. Remember that the slope, is going to be the change in y, which in this case is from 15 to 18 is 1013 minus 0.6025 minus 910.80925. That is going to be your change in y. And then that's going to go over your change in x. Which is 15 minus 8. Okay. Now, if we do some arithmetic here, let's get our calculator out.
I have a question.
Yes.
Can I see how you wrote down the problem at the top? Because I put it in the same way and it's not coming up for me.
Absolutely. Actually, I think if I close it, it'll come out quick. Let's do that. Nope, that's not it. Oh, I got it back. Okay. Hold on. It's funny, it just won't give you a glimpse of it. Oh, that's horrible. It won't tell you.
Because I did the same thing, but it's just giving me a table with no numbers.
Are you sure you put minus in there? That's a common mistake.
Yeah, I did put it in there.
Okay. Let's see. Well, I'll tell you what. Let me finish this one, and then
right.
and then I'll look at your work. If you don't mind, maybe you could share it, and I could look at it for you. If
All
that's
right.
all right with you.
Thank
All right.
you.
Let's finish this one slope, and then let's do that. Okay.
Thanks.
So this is going to be on top that number minus 910.80925. I'm getting 102. It's 79325. And of course, that's going to be over -3. Don't let that fool you. It is over -3. And then divided by -3. I'm getting -34.26. Okay, let's check to see if that's right now. There you go, 34.26 per year. It is a decrease, so it's going to be that. So I hope that helped you out a little bit with that question. And in the meanwhile, we have a student who wanted to share. So why don't we take a look at that? And I do have the formula written right here. Oh, something else that you might want to make sure of. Looking at the question. No, it is the same. Everybody's got the same function. Okay, I'm going to stop the share. Okay, great. And now I have allowed sharing. So I'm going to ask you to go ahead and share it, and we'll take a look at it.
How do I share it?
You can share it if you look at the bottom. There's like a little taskbar here, and if it's not there, if you just point there, it'll kind of come up like this. And then in the middle, you should see a thing that says share screen, and it should be green.
There's one that says live. Do I click that or?
Oh,
Yeah, it says live transcription.
try it. I don't know. Try it. Oh, live transcription. That'll give you like the words that we're saying. Should be able to share the screen.
No, I only see participants, chat, live, reaction, settings, and more. That's it.
Go to more.
It says stop incoming video.
That's odd. I thought you'd be able to share the screen. Oh well. I'm sorry that won't work. Let's see. How can we figure this out? Well,
Yeah, but for the way I put it, it's the exact same way, and
Yeah.
I just clicked. Right now I'm doing it. I click table, and it's just empty.
There it is. There it is. I got it back. Look closely at it. How does it look? Um,
Yeah,
maybe,
it's the same. It's the same way.
is it 0.005 and not 0.05? It's only 0.005.
Hold on, let me see.
Look closely at it. It should be 120,000, 1, 2, and then 4 zeros. Those little things are just the kind of thing that'll get you, you know.
Yeah, it's the same way, and it just keeps coming up like with no numbers.
When you do it, let me ask you, when you click it like this, do you at least get,
No, I have this thing on the left with like a warning sign,
okay, all right.
and it says points are written like this. That's what it says.
I wish I could see it. I hate it that I can't see it. Oh, um, all right. Uh, hmm.
Right now, I just screenshotted it. I'm gonna send you through.
Excellent. Let's look at that. That's a great plan. Let's look at it that way.
All right, I sent it.
Okay, in the email?
Yes.
Okay, let me go look for it. Got it. Got it. Oh, you put a comma in. That's your problem. You put a comma in. Take the comma out.
Oh, okay, I got you now. All right.
Got it?
Yeah.
That's
Now,
what you get for being a good student, okay? Don't put comma.
gotcha. All right. Thank you.
You're welcome. No
I had
problem.
a question before web sign 4 I put.
Yeah, there's a couple more too, so let's get to those. Okay, so taking a look at these questions, the first one says reverse the roles of the variables by solving for the indicated variable. And we have a formula. This, if you're familiar, this is temperature. This is about Fahrenheit and Celsius. Now, let's see if we can solve. I'm going to try to use my handwriting here, and bear with me, but that's kind of the best way to go about this. I've got F equals 9/5 C plus 32. Now, to solve this, you're trying to solve it for C. So I want you to take into consideration that you're hoping to get C completely isolated, and you want to pull everything away from C, so it's just C on the other side there. Now, you can choose to get rid of the 32, or you could choose to get rid of the 9/5. Which one do you want to do first? The answer is get rid of the 32 first. If you get rid of the 32 first, like so, and please forgive my handwriting. I know it looks horrible, but I'm writing with a mouse here. These will cancel. And you're going to have on the left F minus 32, because you can't figure out F minus 32. So what's the answer to that? It's F minus 32 equals 9/5 C. Now, if you ever tried to isolate a variable that's being multiplied by a fraction, you're supposed to divide by the fraction. And when you divide by a fraction, That's the same as multiplying by the reciprocal. You knew I was going to say that, didn't you? Well, I want you to remember that every time you're ever looking at 5/9 c or 1/3 x, multiply it by the reciprocal, and the reciprocal and the fraction will collapse nicely, and you'll be left with the isolated c there. So what I'll do right now, and I'll do it in red, is I'm going to multiply both sides by the very uncomfortable 5/9. And you'll notice, unfortunately, the 9s go and the 5s go. Well, fortunately, not unfortunately, but fortunately, which leaves on the left-hand side, if you look very closely, that's exactly what we have here. Now, you could have written it the way that they have it there, or you could write it the way I have it here. Over there, what they did was they took the 5, they took the 5, I'm sorry, not the 5. They took the f over 32 and acted like it was its own fraction. Like it's over 1, and then that quantity, f minus 32, can get multiplied by the 5, and that's the new numerator. And then on the bottom, you have just 9 times 1, which is the 9. All right, so that's how you figure out part 7. I hope that makes sense. Any questions about it? All right, let me know if you have any questions about it. Okay, let's carry on now, and let's try to do the next question. I'm going to undo these. Okay. Initially, you have an inventory of 3,600 sweaters on hand. You sell 600 sweaters each week. Use S for the total number of sweaters remaining in your inventory, and show W for the number of weeks, and find the formula that gives S as a function of W. Okay. I see. Okay, the only thing that's different from the answer, as you can see, is that the plus sign is there, and it should have been a minus. This looks like what the situation would be if you had 3,600 sweaters and then you bought 600 every single week. It's not that you're buying 600 every single week, you're selling 600 every single week. So we should be having a minus there. That's why that one's incorrect. You were very, very close. You have the polynomial almost exactly right. It's just the minus should have been a plus. I hope that makes sense for these 2 questions. There's a couple more questions we're going to get to also. If there's any questions, I'm going to pause the recording and move on to the next couple questions.
It was just as well 11 and 12.
Okay.
And I don't know if you have it there, but mine says 10. I don't see 10 on yours. You only have a 9.
Oh, okay. Yeah, let's go get that. Okay, friends, we're going to look at number 10 now. And number 10 says, you are ordering fast food for your family. The burgers you are ordering have a total of 19 grams of trans fat. Fries have 7 grams of trans fat for order. Part A, find a formula that gives the total grams T of trans fat in your order if you add F orders of fries. Okay, the reason why this is the correct answer here for this one is because we already are going to get 19 grams of trans fat in our order right off the bat. Every time that we order fries again, there's going to be 7 more. And if there are F orders of fries, then 7F represents the money that is spent on fries. If you add that to the original 19, not the money, but the grams the grams of trans fat you get from the fries. If you add that to the 19, then you have your solution. How many orders of fries can you get if you want to limit your family's trans fat intake in this meal to 40 grams? The way we're going to figure that out is you write out either an equation or an inequality. It's up to you. But the appropriate way to go about it is to make an inequality. Well, it says limit their intake to 40. Yeah, that it has to be less than or equal to 40. Let's just make it equal to 40. Meaning 40 is the most. If we work through the motions of solving this, it would look something like this. Minus 19. Minus 19. Oops. My hand slipped there. 7F equals 21. Divide both sides by 7. And that's why I have 3. Okay, I hope that makes sense. While we're at it, let's look at the next one. A manufacturer of t-shirts has fixed costs of $4,200 per month. These are monthly costs that are incurred no matter how many t-shirts are produced. That is what fixed costs are. You pay them every month, like it or not. Has nothing to do with what you're doing in the factory, right? It's like employees, salaries, um, utility bills, things like that. You have to pay 4,200 a month period if you want to operate. There are variable costs of $8 per t-shirt. That is, it costs $8 to produce each additional t-shirt. And by the way, the t-shirts will sell for $12 each. So if you want the cost function, it's going to give the cost in dollars of producing t-shirts. The cost is going to start with the piece that is a constant, regular, fixed cost right here, 4,200. And then you're going to think about how much it costs to make one shirt, $8, multiplied by the number of shirts you're going to make, T. That's why the cost function always has those three elements. It has the fixed costs, and then it has the cost to make one unit or widget or t-shirt or whatever, times the variable representing the number of t-shirts. That's what we want for our cost function there. The revenue function is going to be simply the number of t-shirts times the price you're selling it for. That's why it's 12T. Remember, T is the number of t-shirts that you're going to be producing, right? So if it sells for $12 each, we can assume that the revenue function is 12 times T. In other words, how much money are you going to bring into your cash register? You're going to bring in $12 times however many shirts you sell. And last but not least, we have something we like to call the break-even point. The break-even point is the number of t-shirts produced and sold that results in a net income of $0. That is when cost equals revenue. Find the break-even point. So I want you to try to imagine you're selling these t-shirts, but before you were able to even start selling the t-shirts, you had to lay down $4,200. You had to spend $8 for every t-shirt you made, and then you set up shop and started selling t-shirts. Imagine you're in the mall. There will come a specific perfect moment when one customer buys a t-shirt and suddenly everything is paid for, and you're at that moment where you're starting to make a profit. You're no longer in debt from the money you put into the company. Now you're finally at a perfect zero, and now every shirt that comes in is going to bring more money into your company, and you're going to start seeing a positive profit. That perfect moment is called the break-even moment. There's two ways to figure out the break-even. You could say, when is the profit equal to zero? That's the break-even moment. Or you could say, when does the cost equal the profit? Because that's the time when everything balances perfectly. In other words, what I need to get that is to solve the equation of this equals this, something like this. 8T plus 4,200 plus 12T equals 12T. This is the equation that you need to get the answer. You'll get 1050 as your answer. How do I solve that equation? Well, I'll start by pulling the 8T out. Then I'm going to draw a line to show that I mean to subtract, and consequently these knock out. And now I have a new statement, 4,200 equals 4T. And then I can divide both sides by 4 now. When you do that, you get 1050. Yep, 1050. Okay, so that question is a little bit of a different kind of question because we have not discussed cost, revenue, and profit. That is a regular recurring theme in math models because it's the most basic business model out there. And those of you who are business majors, you will be using that model a lot. If you take quantitative analysis 1, which I'm teaching in the summer, if you'd like to come and take it, by the way, quantitative analysis 1 really dives in deep with the cost, revenue, and profit. But the most basic concept in it is that the cost equals the revenue when you're at the breaking point. You could also say the profit is 0 for a second when you're at that breaking point, and that's how you find the break-even point. Okay, one more question I have here. Let's scroll down, and I have a couple more also in the list, and I will address those as well. It says, pay scale 1. A small business is considering hiring a new sales representative or sales rep, plus a commission of 7% of total yearly sales. Pay scale 2. Pay the sales rep, pay scale 1. Oh, I'm sorry, I think I read that incorrectly. I did. A small business is considering hiring a new representative or sales rep to market its product in a nearby city. Two pay scales are under consideration. I totally read that wrong, excuse me. Pay scale 1, pay the sales rep a base yearly salary of this much plus a commission of this much. Pay scale 2, pay the sales rep a base yearly salary of this much plus a commission of that much. Now, for each of the pay scales above, use a formula to express the total earnings. Take a close look, friends. It should be clear to you knowing those ideas. You're going to get 1,250 right off the bat. 12,500 right off the bat, plus 7% of all of your sales. If your sales is S, then it looks like this in the story. Same thing goes here, 1,700 base, 0.04 times the sales S. So for part A, I hope that that's clear. That's how you would figure those out, okay? For part B, it's saying, what amount of total yearly sales would result in the same total yearly earnings for the sales rep, no matter which of the two pay scales is used? Easiest way to do that is to just solve the two equations. I would go right in with 12,500 plus 0.07 S equals 17,000 plus 0.04 S. For a question like this, I would encourage you to use Desmos. You could use, of course, old algebra ability, but this is going to come out really quick if we use Desmos. Let me show you how to solve an equation with Desmos now. The first equation is 12,500 plus 0.07 S. I'm going to use X and Y. $12,500 plus 0.07 X. The next equation is going to read 17,000 plus 0.04 X. Now, those are very strange looking lines. Let's see if we can find them on the graph and see where they cross. I'm going to click home first. I don't see them in the immediate vicinity. Let's zoom out a whole bunch. Keep going. Keep going. There they are. Where do they cross? Keep going. Click somewhere in the area. Okay. The answer is 150,000. Wasn't that easy? All you have to do is say y equals the left side of the equation, then y equals the right side of the equation, and see where they cross. The x value is the solution. You could do that with any equation. You could do that with equations that have e in them, logarithms in them, cosine and sine in them, any kind of ugly equation you can dream up. If you put y equals the left side and y equals the right side into Desmos, the place or places where they cross are the solution or solutions. The answer is 150,000. So we'll come back and take a look. There's your solution, 150,000. On the same screen, plot the graphs like I just did, right? And now let's take a look at the scale here. Notice the scale for these. It's going to go all the way up to 40 grand. Here it's going to go all the way up to 300,000. So for the X, I'm going to go 0 to 300,000. Let's do that first. Okay. And then for the Y, I'm going to go from 0 to 40,000. Okay, now look at it. Doesn't it look like one of your multiple choice guesses? You're never going to be able to get it unless you change those axes with the wrench. I'm telling you, that is the whole trick to getting these. And as soon as you do that, it suddenly becomes really very, very simple. I think you could see which one of these is the correct answer. Some things that I'm really going to harp on here are that it goes right through there. I also see that right here, it's kind of between 15. Let me illustrate. Right here, it's like around maybe 12.5 and then almost exactly 17. I'm going to use those as an example. 12.5 and 17 are the intercepts. So let's go back and look closely here. 12.5 and 17 can't be this one, right? 12.5 and 17 can't be this one. 12.5 and 17 can't be this one. It's got to be this one. And as you can see, there it is. Right? Okay, so I hope that helps a little bit. Again, it's a matter of using the wrench to get those right. If you were a sales rep negotiating for the new position, under what conditions would you prefer pay scale 1? And the answer is when you expect total sales to exceed 150,000. In other words, you can see that in the very specific case of 150,000, which I could represent really by this line right here, At this point, what happens is the red line is above the blue line everywhere. Like, see where the red line is right here? All throughout that region from 150,000 on, the red line is always above the blue line, which means you'll always get paid more if you sell more than 150,000. That's why that's what the answer is there. The last part says, under what conditions would you prefer pay scale 2? If I was going to sell less than 150,000, because as you can see back here, pay scale 2 is on top all throughout up until you get to 150,000. That is the idea of break-even analysis, finding those regions of places where the profit is better if you go with this method versus that method. It's the whole idea there. Okay, so I'm going to clear that. And I do have a couple more questions, but before I talk about those questions, I have a couple students sitting with me here in class, and I just want to mention it is 2:35 and we're technically supposed to dismiss. I'm going to answer all the rest of the questions, though, that are here. If you have the time to stick around, I'd be very happy to stay here and work with you for a little bit while longer to get them, because I have like 3 questions. If you feel like you know them and you don't need to stay, you don't have to stay, but I feel obligated, like I want to explain them. So I'm going to go in now and I'm going to go and get the next couple questions. Thanks for your attention, guys. I know it's a little bit late. If you can stick around, take a look at what I'm about to do, okay? Okay, so for this one, the way we'll do it is we'll put it right into Desmos. The formula is 2 to the x minus x cubed plus 900.
I have a question. Is that WebAssign 4 or 3 that you're doing?
Let's take a look. That would be WebAssign 3. That's WebAssign 3.
Gotcha.
2 to the x minus x cubed. And then plus 900. Okay, so the question is telling you that it's only going to go from 0 to 10, and we want to know what is the max value. So let's go and get a table now. And let's go only from 0 to 10. Oh, I didn't mean to copy it. Let's go only from 0 to 10. And let's look for, I know I just said it, but what was it? Maximum? Yeah. Okay, maximum value. Where's the maximum value here? Let's take a look then. The maximum value is actually right here, isn't it? Is there anything bigger than that? That's it. 10 is the maximum value. So what that means is when x is 10 is at its greatest and the actual value itself is 924 for that question. There we go. And that's what we have. All right. Another good question here I have. I can move that to answered. Okay. This one came from Tag. And we want to look just at part C, okay? Okay, calculate G of 24. Okay, to calculate G of 24, that's actually really easy to do if you use Desmos. So let's take this formula and put it in Desmos. Remember, I want to convert it into terms of y and x. So I'm going to say y equals negative 0.25x squared plus 5x, like that. So I'm using x instead of n. Negative 0.25 x squared plus 5x. Okay. Let me just check that. Is that right? Okay. And they would like, please, G of 24, they're asking. So to make it really easy, change it into a table. And then go into the space and type 24. Bingo, there's the answer, quick and easy. Negative 24 is the solution to that. And as you can see, that's what they have right there. Right. I think the rest of this question is fine. So let's move on to the next question. I'm going to say move to answered. And now I have Tom has a question. Okay. Looks like we're going to focus on the last one. I can see that you have a good grasp on all of them except the last one. Let's just focus on the last one, okay? And the last one says the break-even point is the number of t-shirts produced and sold that results in the net income of $0. That is when cost equals revenue. Now, look, you do have a cost and you do have a revenue. So what you're asked to do really is to solve this equation here. 9t plus 4100 equals 11t. Okay, just for a good exercise, let's do it with Desmos. I'll make it y equals the left side and y equals right side. So it'll be y equals 9x plus 4100. And then the other one will be y equals 11x. Okay, let's zoom out and see if we can figure out where these things cross. They cross all the way up there. It's not very clear where they cross, but I can see that they do cross. And look at how Desmos gave you the point of cross, right? So the break-even point happens at x equals 2050. Is that even possible? Is that right? Yeah, that's it, 2050. That's what they wanted. It's a lot easier if we use Desmos. It's almost hard to believe how quick and easy it comes out that way. All right, I'm going to stop the share, and I'm going to stop our recording, and I'm about to dismiss. Thanks for your attention, guys. This will be posted on eCampus.